In artificial neural network, ANN, we are taking interview questions and answers. Explain neural network. So neural network is a sequence of algorithm that gives its best to recognize the underlying relationship in a data set through a process. So neural network is all about mimicking the human brain, neurons. So the artificial neural network has similarities and differences from biological brains. We have the deep learning concept, and in the next question we will talk about how this biological brain or neuron, how they are mimicked in neural network. So explain the biological neural network and artificial neural network. So if you see here, so biological neural network is through neurons. We have real neurons in our body, in our brain. So our nervous system understand and learn and is based on neurons and the different sensory organs. So the biological neural network is our nervous system in which the neurons are linked with each other. So human has a mind to understand, and human can operate on any task. It can understand and it can react to any particular situation. But how a robot or a machine or a computer will do that? For that, artificial brain, that is mimicking of the human brain, is done, which is called as a neural network. So the human brain has neurons to transfer the information or data. Similarly, in neural network we have nodes that perform the same task, and these are all mathematical functions only. See, these are the input, then we give weights, then these are multiplied and added, passed through with a bias, it is passed through an activation function. And then there are so many things which we are going to discuss just now, which are happening. Define activation function. So the name is suggesting activation function activates a neuron in the neural network. So here we have inputs. For example, you want to find out whether a human is a male or a female. Okay. So what will you give? Say weight, say height. That is the weight and height. There can be other input also. Let us assume weight and height are the x1, x2, that is the inputs. We want to find whether it is a male or a female. So normally the girl's height or boy's height are higher. So we give them this height a higher weight, 0.8, and the 0.2 as lower. So we multiply these two and then we add them. So there will be a bias also. We'll talk about bias in just in a short while. Then we pass it through a transfer. This is an activation function. So this is computation. Then it passed through the activation function. This activation function is going to activate or deactivate. That is, we get a proper value here with WIXI, that is weight into the input value, weights into the input value plus the bias. Now this is sent to the activation function. Activation function, what it does, because the value which is coming can be any value. So it is very hard or complex to handle these numbers of value. So why not to pass through a function so that we get a boundary value, that is a value which is under certain boundary. For example, sigmoid function, it always gives you a value between 0 and 1. There are functions which are giving value between -1 and 1. So it becomes very easy to manage when it comes out of activation function. So the numbers can be different for every, say, output. So it's better to have an activation function, and this activation function are simply, for example, this sigmoid is simply 1 by 1 plus e to the power minus x. This is the mathematical function. Explain the loss function. So what is a loss? What we are talking about loss? We want this loss to be as minimum possible. Assume it to be a neural network. As I said, weight and height we are giving. we want to find out whether the person whose weight and height is given is a male or a female. These are hidden layers, H1, H2, output is O1. So loss function in the network, we are talking about whatever is output. For example, we are trying to find out males or female. Say for male we have 1 or 0, or say female we have 0. Male 1, female 0. So the output should be 1 or 0, but the output is coming 0.5. That is neither a male nor a female. So there is a problem. What do? We cannot change a weight or a height of a single person. That will remain the same for a person. So the weights we have given and the biases we have given, this is in our hand. We control it. So the loss function is all about controlling and changing the weights and the biases. So how to write this? We can write this like this. Loss function is the function of weights and biases. That is L, W, comma B, weight and biases. How many weights are there? For example, this particular example, W1, W2, W3, W4, W5, W6. Bias we are going to talk about. Bias is just for, we don't want everything to pass through the origin. We want realistic way of dealing with this. So how many weights are there? 6 weights. How many biases are there? B1, B2, B3. So if you see here, we have a function which is having 6 variable of weight and 3 variable of biases. So now we want to change the weight W1. We want to change W1. Then we'll change W2. So when we are changing W1 or W2, we want all others to be constant. That is only can be done through partial derivative. So this is partial derivative. Del L by del W1 means we are just dealing with W1, and then all others we are keeping the constant. So this capital L, wherever I'm talking, this is the loss function. This is the loss function we are talking about. How can we help artificial neurons in learning? Artificial neuron in learning. So we need to educate the artificial neural network or neurons. For example, as I said, male is 1, female is 0. We need to have an output as 1 and 0 only. We cannot have a 0.5 or 0.6 or a 0.7, 0.8. We want some genuine or realistic output to be showed by the artificial neural network. So in order to do this, there are 2 ways in which we can make this artificial neuron learn. The first step is associative mapping, in which we work on the pattern with the given input and produce the pattern output. For example, you are giving an image. Now it is a dog or a cat, so you have to give the features. So this pattern, this is the associative mapping. So we work on the pattern and which we give as an input. So that should produce the pattern output. So pattern input, pattern output, this is through associative mapping, right? This is the first way you can make the artificial neural network learn. And then the second step is units are learning. So there are units like the weights and the biases. This should learn. Learning of unit is essential to respond to the particular properties of the input pattern. What is the use of artificial neural network, ANN? So I am just pointing few: handwriting recognition. But there are plenty of use and applications of ANN. Traveling salesman problem. This is a very classic problem of computer science and mathematics. So it is able to solve that also. That is visiting only one city once. The person has to visit image compression, image denoising, stock exchange prediction. So these are all the different use and application of artificial neural network. So because it is an interview question, you just have to think that you are developing a robot, that is a machine with human capabilities. So what if not? These are the decision which a human can make. So without any problem or with precision, what if and what if not, this neural network should also answer. So there are adaptive learning, self-organizing maps, real-time operation. All these you can also include. But the main thing is these 4, if you say, this will make the interviewer know that you know about the application and basic usages of this network. What is a bias? Now if you see here, this is a perceptron, that is a neuron with single output. Now this perceptron, I just showed one bias. There will be bias for every neuron, okay? So bias is added to the x1 into w1, then it is passed through the activation function. So why we use bias? For example, this is a general equation of a straight line, y equals mx plus c. So this x1, x2, xn are the independent variable. Y is a dependent variable. Y you want to get, x you are inputting, m are the weights. So if you don't put c, that is c, we are calling it as a bias. What will happen if c is not there? Bias is just like an intercept added in a linear equation. If you are not giving c is 0, then a line will pass always through the origin. The result will always be centered. We want a realistic solution. So it is an additional parameter in the neural network which is used to adjust the output along with the weighted sum of the inputs to the neuron. We are shifting it. And moreover, the bias value allows you to shift the activation function also to either right or left. So we are adjusting the final output also and the activation function also. Define error function. So error function is all about, let me give you an example, then you will understand. If I tell you to go and bring $10 from someone, you go, you come back with $6. What is the error? 4. 10 minus 6 is 4. I told you to get $10, you brought $12. The error is minus 2. So this 4 and minus 2 is the error. That is the true value and predicted value are different. If I say 10 and you get 10, 10 minus 10, error is 0. I will not say anything to you. But if you give me error 4 or minus 2, then I have to do something. I have to minimize the error. I have to go to the person, either request him 4 or give him back 2. So this true value and the predicted value, 10 is the true value, predicted value is 6. So the difference of this is the error value. But since negative, positive both are coming, what do? Let us square it, add it, because square will eliminate the negative sign. So just square it, add it, and then you can take the root, square root. You will get the proper value. And this is one data is giving one error. So you have to combine all those errors. So just take an example. We are predicting the gender through weight and height. Alice, Bob, Charlie, Dinah. These are 4 people. These are 4 samples. Okay. So this is the mean squared error, MSE loss I am talking about. This is the error function, MSE. This is nothing but the difference of true value and predicted value, that is 10 minus 6, 10 minus 12 and 10 minus 10, which I just told you. This is the difference. Then we are squaring it because we don't want the negative value to be handled. So we squared it. And because it is for Alice till Dinah we have to do. So we just add all of them. And since we have added them, there are 4 samples. So we divided by n. Okay. So the gender is 1001. This is the actual value because Alice and Dinah are females. If we assume them to be 1, female is 1. But we are getting all males 1111. Say we are getting all females 000 like this. So we have to subtract these two. Y predicted, Y true, we have to subtract, square them, add them. Square them, add them. And then we have to divide it by n. That is the number of samples. So let me tell you again, in this error function, n is the number of samples. Here we have 4 samples, Alice, Bob, Charlie, Dinah. 4. Y is the predicted value, which is, as I said, the dependent value, which is what gender is here. Y true is the true value of the variable, that is the correct answer. For example, Alice is 1. If we assume 1 to be a female and 0 to be a male, then 1 is female. This is a true value of Alice. Y prediction is what? We are getting predicted value. So it can be any value. It cannot be it can be 0.2, 0.3 like this also. So this portion, Y true minus Y predicted whole square, is a squared error. So basically, better predictions means you are lowering the loss. How much you can lower the loss? You have a good prediction. $10, 10 you got, 0 error. We are happy. So we are trying to minimize its loss. That is what we are doing in training a network. explain the supervised and unsupervised learning. So there is a one basic difference. See, supervised learning is a technique in which we train and teach a machine using labeled data. What is a labeled data? So here in the whole data, we have already told that there are three types of balls: red ball, green ball, and say blue ball. Right? So now we already told the machine and we have given the training set. We divide it into a training set and that is training data and the test data. We have a data, we divide them. In unsupervised, we don't tell anything to the machine. We just give the machine an algorithm, give the input, and allow the machine to find out the pattern, the inherent properties of the data, so that it can find out by itself. There are three kinds of balls, and it is its duty of the algorithm to find out. So as I said, supervised learning is a learning technique. We train and using the labeled data. Three types of balls are here. So labeled data means some data which is already tagged with the correct data. It is already tagged. So supervised learning is completed under the guidance of a supervisor. Means there will be, that is why it is supervised, because it has a supervisor. Unsupervised learning, here we train the machine using the data which is neither classified nor labeled. The data is the a priori knowledge is not given to the machine. So this learning algorithm is completed without any guidance or any supervisor. The machine should be able to find out the hidden structure of the unlabeled data. By itself, it has to cluster. It has to make these clusters. Supervised learning, classification is done. Unsupervised learning, clustering is done. So machine learning, supervised learning is classification regression. Unsupervised learning, we have cluster analysis and dimensionality reduction. Which optimization algorithm is best in neural network? Now see, we have already talked about the gradient descent algorithm. So this is if we have thousands of parameters in our neural network, then this gradient descent algorithm is the best one to save the memory. What do? We have a loss function for our neural network. Then we want to change the weights or biases. For that we have del L by del W1. Say we are changing weight 1. We have to do for everything. So we included the predicted value, the hidden output value. Weight 1 we want to change. So weight 1 was initially say some X. Now we have to change it because we found some error. We have to update W1, weight 1. So for that what we'll do? Delta L by delta W1 is the loss function partial derivation. So we multiply it with the learning rate, which is 0.0 to 1.0, any value. Then we subtract this value from W1, and now this weight is updated. And this is done for each and every weight and each and every biases, and then we have to do it again and again. So basically we are optimizing the result. So this is the optimization algorithm. We are not going to the detail of the Levenberg-Magda. It is Marquardt or marked. So this LM, let us say, this is also the best algorithm where we have several neural networks to train with few hundred parameters and a few thousands of instances. This is the LM algorithm. So these are few when you have different kind of data. Do you have any idea about the deep neural network? See, the deep neural network is if you make the neural network deep. That is, if you add multiple hidden layers to a neural network, it will be deep. See, input layer, hidden layer, output layer. This is the general scenario of any neural network. So when the deep neural network is a network with an increased level of complexity, that is the increased number of interconnections and the number of hidden layers. So these deep neural networks, these have more than 2 layers. Okay. Basically, they are dealing with unlabeled or unstructured data. This deep neural network, the deep neural network, as I said, has an output layer, input layer, and at least one hidden layer between them. It can have multiple. That is why it is deep. The number of hidden layers will decide how much deep this deep neural network is. Every layer can perform specific types of sorting and ordering process because every layer is responsible for something. So the output of one is given to the other, and this is being carried forward to the next one. Sometimes we do the back propagation also in this deep neural network. Explain the advantage of artificial neural network. So in traditional programming, if you see, because there are so many advantages. In traditional programming, data or information is stored in database. But the data is stored in the whole network in the neural network. This is the first one. Traditional programming, database. In neural network, data is stored in the whole network. ANN can work with incomplete knowledge also. After providing the training data set to the model, it may produce output even without the complete, or you can say it can work with incomplete information. It is capable of parallel processing. This is because this ANN has a numerical strength that can perform more than one task at same time. ANN has the potential of high tolerance. That is, when these ANN are scaled across multiple machines and multiple servers, so the neural network can route around the missing data or servers and nodes that can't communicate. This is how the high tolerance can be achieved. Even we know about the dropout, we can even leave some of the neurons. The ANN can learn from the examples and apply them when a similar event or task arises and make them work through the real-time event. So this is how we are making the robots. This is how we are making the intelligent machine, like the self-driving cars, etc. So these are the some advantages. If you can add up more, that will be better. But if you are being asked this kind of question, you can give this any of 2 or 3 from these 5 options. Okay. So it is all about automation. It is all about giving the strength of human brain to the machine. How many types of ANN used in machine learning? So there are so many. You can remember these. We have feed-forward neural network, radial basis functions neural network, Cohen self-organizing neural network, recurrent neural network, convolutional. This recurrent is time temporal. Convolutional neural network, especially for images and videos, modular neural network. Explain the feed-forward neural network. Feed-forward neural network. So this feed-forward neural network is a biologically inspired classification algorithm. It consists of a number of simple neuron-like processing units organized in layers, and every unit in a layer is connected with all the units in the previous layer. So this feed forward is going forward. That is, one layer is feeding to the another in a forward manner. So feed forward neural network are ANN where the connections between units do not form a cycle. So this is ANN feed forward neural network, but the first type of ANN is being invented without any cycle. And they are called feed forward because information only travels forward in the network, no loops. No looping is there. First through the input node, then through the hidden nodes, if it is present, and then finally through the output nodes. So one thing is very clear about this is you have to speak that it should not have any loops. What is convolution neural network or CNN? This is also a neural network because the conventional neural network couldn't handle the images. For example, if we have a simple image like this, and now we want to find out some feature or a pattern, what do? Normal image processing, we take a filter or we take a kernel and then we put it on one of the 3x3 because this is 3x3. Then we shift it to cover all the pixels of the image. And this is a very time consuming and you can say a heavy kind of work. So convolution is this only. So this CNN is a type of ANN used in image recognition, video processing and processing that is specifically designed to process the pixel data. So CNN have their neurons arranged more like than those of the frontal lobe, the area responsible for processing visual stimuli in human and other animals. So let us give you an example. For example, this is a car. So take a part. There are 3 parts. First, let us understand the part. One is the convolution part. then we have the pooling part, and then we have the flattening parts. This is essential for CNN. So first we do the convolution as I just suggested. Then we apply the any activation function like ReLU, etc. Then we do the pooling. So we have to combine the data also. That is pooling. We have to do that. Then we do this we can do multiple times. So convolution, ReLU, pooling, convolution, ReLU, pooling. This is the part of feature learning process of a CNN. After that, we do the classification. For that, we have to flatten. As I said, there is humongous type of amount of data. We have to just flatten this. And finally, we can again apply, say, if softmax, it is again an activation function. So this is how the CNN would work. You have to remember feature. What do you mean by combination function in neural network? So there is one more question which is coming. So combination function is the vector to scalar function where each non-input combines the value that is fed into neural network via synaptic connection from other units producing the net input. So what does it mean? Linear combination function. We have already seen x1 is input, w1 is weight. So we multiply x with w. All the x and w we multiply, we add them with the bias. And then we call it as a linear combination function. Okay. Then we have another which is RBF. So we know the distance, Euclidean distance it uses, which is the Euclidean distance combination function as in RBF. RBF is coming just now. So this, you don't have to go to the mathematics, just understand distance, then that is given to the H, which is the hidden layer, that is passed through, and then finally the value is computed. So there are different kind of computation which can be done so that we arrive at a proper output. What is RBFNN? So in the field of mathematical modeling, a radial basis function network. So RBFNN, radial basis function network. So this is an ANN that uses a radial basis function as activation function. So in this RBFNN, you have to just tell that this uses radial basis function as activation function. So this is the RBF network. I already told you about this. This is the hidden layer function which will be passed, which has to be passed through multiplication with W. So we are getting some W. We are getting this HX from X minus C, that is a center, and you are finding the distance of every value from the center, and then you are putting it in the function. So this is basically a activation function which is called as a radial basis function. So output of the layer, the network is a linear combination of radial basis functions of the inputs and neuron parameters. Radial basis, distance, Euclidean distance. Okay, this is all about the ANN. Thank you so much. Take care of yourself.